Section 10.4 is about polar coordinates and using our polar coordinates to do the things that we already understand. So I'm going to work through several examples and then just go from there. So our first example is number 2, and it says r equals cosine theta, and it's between 0, theta is between 0 and pi over 6. And the directions say find the area of the region bounded by the given curve that lies in the specified sector. So let's look at what that curve looks like. So put it in your calculator, make sure you're in polar coordinates. If you plot the points, it ends up looking something like, here's one, it's like a part of an arc. So the area bounded by this region looks like what I've drawn here. Now, what's important is that when we find the area bounded by a polar chord in a given sector, what we're looking at a part of a circle. So it goes back to that geometry formula that you probably don't remember. But the area of a sector, and a sector is shaped like this, which looks like a lot like what we have. So this is theta and this is r, and the area of a sector is 1/2 r squared theta. So when we use our calculus, that's our high school formula from high school geometry, so any kind of geometry. So when we use our formula to find the area, we say area equals 1/2 the integration from a to b, and then we have r squared d theta. So this is our formula right here for area of a polar region. It's based upon the one above, but this is our formula for area of a polar region. And remember that r is already in terms of theta, so that's set up nicely for us. So let's go back to number 2, and we're going to say the area is 1/2. Now they do have the 1/2 inside, but I'm going to leave it outside. And our bounds are 0 to pi over 6. And then we have r, so we have cosine of theta, quantity squared d theta. So it's set up well, but we can't integrate cosine squared. So let's say 1/2 the integration from 0 to pi over 6. And cosine squared, let's replace it with 1/2. 1 plus cosine of 2 theta d theta. Now a lot of people do this poorly. So let's put these 1/2s together and distribute them to be 1/4, because that's where a lot of students mess up. A lot of people in general, not just students. Oops. So let's call this 1/4 plus 1/4 cosine 2 theta. Now the reason this is important is because we have to use u sub in the second part. So let's split it into 2 integrals, 0 to pi over 6, 1/4 d theta, plus the integral from 0 to pi over 6, 1/4 cosine 2 theta d theta. Now we let u equal 2 theta, so du equals 2 d theta, so d theta equals 1/2 du. So that means we have the integration from 0 to pi over 6 of 1/4 d theta, plus the integration from 0 to pi over 6, and I have 1/4 times 1/2, so we have 1/8 cosine of u du. If you need to, pause and think about that, but that's from this 1/2 du. So now we can integrate, and we get 1/4 of d theta is 1/4 theta, plus 1/8, and the integration of cosine is sine of u from 0 to pi over 6. So we can call this 1/4 theta plus 1/8, and this really is sine of 2 theta from 0 to pi over 6. So let's plug in pi over 6. We have 1/4 times pi over 6 plus 1/8 times sine of 2 pi over 6 is sine of pi over 3. I don't know about you, but I need my triangles to make this happen. So square root of 3 is across from 3. 2 is on the hypotenuse. 1 is here. Sine of pi over 3 is square root of 3 over 2. Minus 1/4 of 0 is 0. And sine of 0 is 0. So we have pi over 24 plus the square root of 3 over 16. And that's our area of the polar region. So let's look at one where they give you a graph. Let me bring that graph into this. Now we can see this bounded area is from, here we have pi, this is pi, and this is pi over 2. So we're going to use the area formula. Area is 1/2 times the integration from a to b of r squared d theta. So we're going to say 1/2 times the integration from pi over 2 to pi, and our radius is 2 plus cosine theta d theta squared d theta. So that's 1/2 the integration from pi over 2 to pi, and when we multiply that out using FOIL, we get 4 plus 4 cosine theta plus cosine squared theta d theta. So let's distribute that half right away. Otherwise, you might lose it. So we have we're going to distribute the 1/2. Let's try that again. So let's distribute that 1/2 right away. Otherwise, you might lose it. So we have the bounds from pi over 2 to pi. We have 2 plus 2 cosine theta plus 1/2 cosine squared theta d theta. Now you can't integrate cosine squared because there's no sign to go with it. These two you can integrate right off the bat. So let's break that into two separate integrals. So let's say the integration from pi over 2 to pi, and we have 2 plus 2 cosine theta d theta plus the integration from pi over 2 to pi, and we have 1/2, and instead of cosine squared, remember that cosine squared theta can be written as 1/2 times 1 plus cosine 2 theta. Let's put that in. So we have 1/2 times, that's the 1/2 in front of it, and here's the 1/2 in the identity, 1 plus cosine 2 theta d theta. So let's distribute that 1/2 because most people do that incorrectly. So here we have 2 plus 2 cosine theta d theta plus the integration from pi over 2 to pi, and I have 1/4 plus 1/2, I'm sorry, that's a 1/4, plus 1/4 cosine 2 theta d theta. So this is going to require u sub. Let's let u be 2 theta. So du is 2 d theta. So d theta is 1/2 du. So we're going to have to split that integral because you can't mix and match thetas and u's. So here we have 2 plus 2 cosine theta d theta plus the integration from pi over 2 to pi of 1/4 d theta plus the integration from pi over 2 to pi, and here I have 1/4 times 1/2. 1/4 times 1/2 cosine of u du. So that's the 1/4 here and the 1/2 in the du. So now we can actually integrate. Let's do that. So 2 becomes 2 theta. Notice the bounds are the same all the way across. So we're going to put bounds at the end. So we have 2 theta plus 2, and the antiderivative of cosine of theta is sine theta, plus 1/4 theta, plus 1/8, and the integration of cosine is sine u from pi over 2 to pi. So now we need one more line here before we can actually do the math. 2 theta plus 2 sine theta plus 1/4 theta plus 1/8 sine of 2 theta from pi over 2 to pi. So now let's put in pi. So 2 times pi is 2 pi plus sine of pi is 0 plus 1/4 pi plus sine of 2 pi is 0 minus, we have 2 times pi over 2 plus sine of pi over 2 is 1 times 2 is 2. We'll say times 1 so we don't forget we did it. Plus 1/4 times pi over 2 plus 2 times pi over 2 is pi, and sine of pi is 0. And so now we have 2 pi plus pi over 4 minus pi minus 2 minus pi over 8. So let's get common denominators, even on the 2. So the common denominator is 8. So this will be 16 pi over 8 plus 2 pi over 8 minus 8 pi over 8 minus 16 over 8 minus pi over 8. So if you look at all the pi's, we have 16 plus 2 is 18, minus 8 is 10, minus 1 is 9 pi over 8, minus 16 over, we could say minus 2, or we can make it a big fraction and say 9 pi minus 2, 9 pi minus 16 all over 8. Because we found common denominators, we could say 9 pi over 8 minus the number 2. Either of these is good. I'm not sure what, let me check real quick what the back of your book says. The back of your book has the second answer. Both are good. It doesn't matter. Let's do another problem. The rest of the problems are all talking about finding the area, and so you just keep doing the same problem. Let's talk about, this one says, find the area of the region that lies inside both curves. So r equals 3 sine theta and r equals 3 cosine of theta. So if we look at these graphs, 3 sine theta is a circle sitting up here, and 3 cosine theta is a circle sitting here. They both have a radius of 1. One of mine looks bigger than the others. That's because I don't draw perfect circles. So we're looking for this area here where they overlap. And in order to find point of intersection ever, we set them equal to each other. So we're going to say 3 sine theta equals 3 cosine theta. So if we divide by 3's, we find that sine of theta equals cosine of theta. We know this happens. We could divide and say, now I know this happens at pi over 4. So if you know that, you could stop here. We could say sine theta over cosine theta equals 1, tangent theta equals 1, theta equals pi over 4. So we know that it's true at pi over 4. Now what we have here is we have to look at the graph, and this is 0 to pi over 4 for the sine graph. And then this is, the other part is pi over 4 to pi over 2 on the cosine graph. So we're going to have to find these two areas separately and add them together. But remember these shapes from high school geometry. In order to find the area of the whole shape, you divide it into regions, and you find the areas and add them together. That's what we're doing here. We're going to find, because this is technically cut by a line, so we're going to find those regions and find the area. So we're going to say the area equals 1/2 the integration from 0 to pi over 4 of 3 sine theta quantity squared with respect to theta, plus 1/2 the area from pi over 4 to pi over 2, and we have 3 cosine of theta quantity squared d theta. So let's square it. We have 1/2 the integration from 0 to pi over 4, 9 sine squared theta d theta, plus 1/2 the integration from pi over 4 to pi over 2, 9 cosine squared theta d theta. Now, I always keep mine in one long line. I know that several of you split them and look at the two separately, and then we'll add the answers at the end, and that's acceptable as well. But let's look at this. So I have 9 over 2 from 0 to pi over 4. And the sine squared is 1/2. 1 minus cosine of 2 theta. D theta. And then we have 9 over 2, the integration from pi over 4 to pi over 2. And we have 1/2, I pulled that 9 out front, 1 plus cosine 2 theta, d theta. Now these are both u sub, and notice they're the same u. So let's take a moment before we get into u sub, because not all of them are, and let's distribute the 9/2, the 1/2, and let's just break it into 4 integrals. So I have 9/2 right here times 1/2, and I'm going to distribute it through the parentheses on both sides and split them into 4 integrals so we can better see what we're doing. So we have 9 over 4, the integral from 0 to pi over 4. Let's put the 9 over 4 inside. That was my internal debate there. Let's do it. Let's do 9 over 4, because 9 over 4 times 1 is 9 over 4 d theta, minus the integration from 0 to pi over 4, and we have 9 over 4 cosine of 2 theta, d theta, plus 9 over 4, the integration from pi over 4 to pi over 2, d theta, plus the integration from pi over 4 to pi over 2, 9 over 4 cosine 2 theta, d theta. Now we're going to use the same u for both of these. Let's let u equal 2 theta, so du then is 2 d theta, which means that d theta equals 1/2 du for this term and for this term. So now we're going to have the integration from 0 to pi over 4 of 9 over 4 d theta minus the integration from 0 to pi over 4 of 9/4 cosine of u du times 1/2 du plus the integration from pi over 4 to pi over 2, 9 over 4 d theta, plus the integration of 9 over 4 cosine of u times 1/2 du from pi over 4 to pi over 2. So now we can integrate, and we get 9/4 theta minus 9/4 times 9 times 1/2 is 9 over 8. And then we have the integration of cosine of u is sine of u, plus 9/4 theta, plus 9/4 times the half is 9/8, and the integration of cosine of u is sine of u. Oh, we don't have the same bounds, so let's split this. The bounds here are 0 to pi over 4, and the bounds here are pi over 4 to pi over 2. Now we need u, so we have 9/4 theta minus 9/8 sine of 2 theta from 0 to pi over 4, plus 9/4 theta plus 9/8 sine 2 theta from pi over 4 to pi over 2. So let's plug in pi over 4. So we have 9 over 4 times pi over 4 minus 9 over 8. And then sine, we're going to take 2 times pi over 4, gives me 2 pi over 4, and that reduces to pi over 2, and sine of that is 1. So we're good there. Minus 0 minus sine of 0 is 0, plus 9 over 4 times pi over 2, plus sine of 2 times pi over 2 is pi, and that sine of that is 0, minus 9 over 4 times pi over 4, plus sine of 2 times pi over 4. 2 times pi over 4 is pi over 2, and sine of that is 1, so it's just 9 over 8. So this gives us 9 pi over 16. Well, 9 pi over 16 minus 9 over 8. This is gone. Plus 9 pi over 8 minus 9 pi over 16 minus 9 over 8. So these two terms cancel. And now you can combine like terms, and we get 9 pi over 8 minus 18 over 8, which gives us 9 pi over 8 minus 9 over 4. And I think that's everything you need to be able to do this lesson. So thank you and have a great day.